Target 8.1. Learning target 8.1. Okay? Okay, hey, let's go. Learning target 8.1. Working with vectors. First of all, what is a vector? A vector is a quantity represented by an arrow with both direction and magnitude. A quantity represented by an arrow with both direction and magnitude. Okay. Now in parentheses, I just have a note to myself there. It says show the notation for vector and magnitude. All right. So there's an example of a vector represented by an arrow.
Technically every arrow then is a vector, right?
Yep, what we'll be when we're drawing arrows, we're drawing a vector. Okay? And a lot of times we'll write this using this notation. This little half arrow right here, that's the notation for vector. Alright? So I'm going to call this vector, vector V. Alright? Just pick any random letter. I could have used R or S or T. But this little half arrow above the letter is indicating a vector. That's the mathematical notation for a vector. Okay? So when you see that in your textbooks or you see me write it, I'm referring to vector V. Or if I put it above an R, it's vector R. Okay? If you see absolute value bars around that, okay? If you see absolute value bars around that vector V notation, this indicates the magnitude or the length of the vector. So if you see absolute value bars around the vector notation, basically it's just telling you to find the length or magnitude of that vector. Magnitude meaning length, okay? I got that?
Oh,
right.
shoot.
Here, I guess I write it even down. Magnitude, I just talked about it. Magnitude is the length of the arrow that you draw, or the amount of force represented by the arrow. So we started getting into story problems, okay? We'll be talking about putting some sort of force on an object, or pushing an object, or pulling an object, or whatever it might be. Whatever way you're pushing or pulling it, it has some sort of magnitude to that force, all right? But again, it's really just going to be the length of the arrow that you draw to represent that force. Okay? So magnitude is length. That's really sums it up. Direction is the direction that the arrow or the vector is going with respect to the positive x-axis. Okay? So in that sense of the word, it's very much like trig. If you have a vector going straight that way, that vector is going at 0 degrees. If you have a vector that's pointed straight up, that vector is going at 90 degrees, 180 degrees, 270 degrees, and so on. Okay? So the direction is always the angle measurement that the arrow is headed with respect to the positive x-axis as being 0. This is where it differs from physics. Have you guys taken physics yet? Anybody?
No.
Okay. A lot of times in physics, this is 0 up here. This is 0 degrees. And then if I remember right, it goes clockwise. So this would be 90, this would be 180, and so on. why physics and trigonometry are different, I probably don't have a great answer for you. I really do not know that. Okay. But a lot of times, north is 0 degrees in physics, but we won't worry about that in here, okay? All right. So, next thing we're going to do here, all right? You're going to have to be able to take a little story problem like this, all right? And make it into a drawing of some sort, the correct arrow that would represent it, okay? So it says draw a vector representing a force of 12 newtons with a direction of, and why that symbol is down there I don't know, but a direction of 100 degrees, okay? So draw a vector representing a force of 12 newtons with a direction of 100 degrees, okay? So, when you go to do this, when you draw a vector, I would first draw your x and y axis, okay? And I'm going to draw a vector of 12 newtons at 100 degrees, okay? First of all, start your vector at the origin. Start your arrow at the origin. And if you're going to draw your arrow in the direction of 100 degrees, where will you be drawing your vector, your arrow? Second quadrant, right? Okay? This part, you don't need to draw it to scale as long as you label it. Okay? (100 degrees). Must be awful. And then label the length 12 newtons. Newton is a label that is given to a force being put on an object. Okay? Newton's a force. Sometimes, besides using 100 degrees to name the direction, they might start using north, south, east, and west. Okay? They would say on this one, they might say 10 degrees west of north.
10 degrees.
So that'd be 100 degrees.
Oh, so.
That would be 10 degrees west of north is exactly this. Because north is right here, right? North is straight up. And this would be 10 degrees to the west of that. Because this is your west. Right?
Too easy.
So you might see that as well. 10 degrees west of north. Or, let me really mess with you, 80 degrees north of west. 80 degrees north of west.
It'd be the same thing.
It's the same thing. Yep. I'm not trying to confuse anybody, but I just want to make sure you're thinking about how they could label it. Okay? This would be 80 degrees right here. So it is 80 degrees to the north of west. It's 80 degrees to the north of where west is. Alright? Any questions on that? How much time do I have?
9:15.
So, any questions on that? Drawing a vector that's a certain magnitude at a certain direction. Okay? Draw a vector representing an airplane flying at 300 miles per hour, 20 degrees south of west. You guys try this one. Okay? Draw a vector representing an airplane flying at 300 miles per hour, 20 degrees south of west.
Too easy. Why am I
20 minutes in and I've had enough.
Give me the test now.
300 miles per hour, 20 degrees south of west.
How do you represent that? Like, you just
Too easy to
Draw an arrow.
yeah, well, I know where to put it at, but I'm trying to help you guys. It's for all you guys.
Always giving, aren't you? 20 degrees south of west. What quadrant?
Third.
Three.
Third.
200
degrees.
200 degrees.
4.
It's 200 degrees.
How'd you?
Said 20 degrees.
200.
South of west.
20 degrees south of west.
So it'd be 200.
It's not degree.
It'd be at 200 is what she's saying.
Yeah.
Where's west?
No, it's not
West.
To the left.
So you're 20 degrees
So
down.
20
80,
degrees
20,
that would be
but
200.
20 degrees down,
Yeah.
okay?
200
Alright,
degrees.
just making sure.
We're gonna
Wait, you feel like it was-
I saw through his bluff the whole time. We're all like arguing, but we're all the same answer.
That's good.
But you're like getting mad at us. You make me feel
I
unlike.
hate you, I hate you, I hate you.
20 degrees south of west, and what do we have, 300 miles per hour?
Yeah. Yeah.
Okay. That would be good right there.
Do we have to draw it in relation to like what it said? Like it said 20 degrees south of west. If we said that it was 200 degrees from east.
Just make sure you label it somehow. So if you went like if you would draw this and then label it with a 200, good? Yep. Okay, everybody okay with that? I'm gonna keep going here so I can hopefully stay under the 15. Everybody good with that? All right. Then it says define horizontal and vertical components of a vector, then find the horizontal and vertical components of the airplane vector above. Write it as an ordered pair using correct notation. Okay? All right. So this is representing the path of an airplane. Okay? The airplane is going 300 miles per hour, 20 degrees south of west. Okay? Well, the airplane is going 20 degrees south of west. Okay? As it's doing that, it has both a vertical and a horizontal component in a sense of this two-dimensional grid here. Okay? It's got both a west component and a south component. It's going a little bit west and a little bit south at the same time, right? You guys follow me? It's not going exactly just one way. So what you could do as well is you could figure out both its horizontal and vertical components. Okay? Horizontal and vertical components. Are we running out of time?
You're at 14.
Yeah, it's all.
Real quick, let it run until 15:01. Go stay.